The 8.5 notes focus on polar ecosystems. And these are the ecosystems that exist up at the poles, such as at the North Pole of our planet, and also in the South Pole, which includes the continent of Antarctica. Let's first focus on the productivity in these ecosystems. They are extremely productive during the summer months, and this, as we've discussed earlier, is because they receive enough light, and because of the melting of the ice, releases an abundance of nutrients in this area. These, in fact, are the only seas productive enough to sustain the populations of large baleen whales. So this is typically where these large whales migrate during the summer to eat. And they eat enough food in the Arctic to support their entire life for the remainder of the year. Now, polar ecosystems have low biodiversity, meaning there's not a lot of different species, but they do have high populations of the species that are present. This is in contrast to what we see on coral reefs, which have an extremely high biodiversity, but low populations of each individual species. We're first going to focus on the Arctic Circle. The Arctic Circle consists of a ring of shallow continental shelf that is unbroken except for where you have the Bering Strait, which is right here, and then also the North Atlantic Ocean. So there are some areas where this Arctic Circle, this Arctic Ocean, has access to the rest of the ocean, but for the most part it is an ocean, a frozen ocean, that is surrounded by continents. So as we've said, most of it is frozen permanently on top of the Earth. And this, of course, gives us many challenges for the organisms that live in this area. First of all, there is reduced sunlight underneath that ice, and the water is barely above freezing. So there has to be some special adaptations to be able to deal with that. And we see that in some fish that live in this area, such as the fish pictured here, which actually has a version of antifreeze within its blood so that it does not freeze. Many of the fish and other animals in this area also have extremely low metabolic rates. So in other words, they just kind of chill out so they don't freeze. So they typically are slow, such as the one example is I believe a six-gill shark that lives in the Arctic area that really is slow and lethargic, but it has to be because it's just so cold. Now the Antarctic is a bit different because it is a continent that is surrounded by sea, rather than in the Arctic, which we saw is a sea surrounded by continents. So we're talking about a totally different area than the North Pole. So the South Pole, or Antarctica, is much different. So as we mentioned, is not enclosed by a continental shelves. In fact, has a continental shelf itself. So if you see this picture that I just pulled up here, this is what the continent itself would look like if we melted all the ice. So all the brownish black stuff you see up there is the actual landmass that sticks up out of the ocean. That light blue area, this area here, is where the continental shelf exists for this landmass. Now, Antarctica is surrounded by the Southern Ocean. It's surrounded by the deepest and broadest and most energetic part of the ocean. So, in fact, sometimes this is called the ice limit. So this actually, this circle of currents that goes around Antarctica helps to kind of separate it from the rest of the world. So it is a very isolated landmass. And as is typical with the Arctic, Antarctic sheet ice typically doubles during the winter. So in this picture you can see here is the continent. All this here that you see in red is all ice. So, and notice this is during September. September for us in the North Pole is rather warm, but for down in the southern hemisphere, that's their winter. Well, during the summertime, as you might expect, ice melts. And notice there's summertime again. This is February. Notice there's very little ice here, but again, this is supposed to happen because it's warmer. So a lot of the sheet ice that surrounds this landmass is gone. It is melted, and then it'll eventually reform again when we get back to winter.